Last time we started addition and subtraction formulas. Formula goes like this. What I told you last time was a sine formula, combines sine and cosine, but preserves what's in the middle part. If it was plus, and then it is connected with plus, and if it was minus, it is connected with minus. But addition and subtraction formula for cosine combines the same type of the trigonometric function. So it goes like cosine and cosine, sine and sine. However, when it comes to addition and subtraction formula for cosine, the middle part will switch the sign. So when angles are added, it becomes minus. When angles are we think about the difference, it becomes sum. For tangent, I said the numerator looks like a distribution, even though mathematically that is not really a distribution. And the denominator is multiplication form, but connection part switches the sign. Plus becomes minus, minus becomes plus. Whatever the way you remember those formulas, you have to remember those formulas very clearly to solve the problem. Today, we continue with the example. The next one is about cosine of 195 degrees. I said the purpose of the using sum and difference formula is we want to calculate the angle value without using calculator by using the well-known angles which are involved to the special triangles. So well-known angles look like 60 degree, 30 degree, and 45 degree, and 90 degree, and so on. When we have this kind of value which we are not familiar with, what we want to do is we want to relate that with the well-known angle. In this particular case, the last digit ends with 5. So in that case, we always relate that with 45 degree. So we rewrite 195 degree with cosine of 45 degree plus 150 degree. And then we apply the sum formula for cosine. Then cosine formula combines the same kind. Cosine starts with cosine and cosine 45 degree. And the same kind is cosine of 150 degree plus, no, not plus, it is minus sine of 45 degree times sine of 150 degree. Let's just draw all the triangle, which we know. 45 degree looks like this, and this is adjacent. This is opposite, and this is hypotenuse. And cosine of 45 degree is 1 over square root of 2, adjacent over hypotenuse. And when we rationalize, that can be written as square root of 2 over 2. I multiplied square root of 2 to the numerator and denominator. And we can do the same thing for cosine, sine 45 degree. Then we get square root of 2 over 2. So we will apply this and then write instead of cosine of 45 and sine of 45. So that becomes square root of 2 over 2 times cosine of 150 degree minus sine of 45 is square root of 2 over 2 times sine of 150 degree. So we have to evaluate sine and cosine of 150 degree. Let's locate the angle in the quadrant. (150 degree is located in the second quadrant. The reference angle is 30 degree. We want to use the special triangle and reference angle to evaluate the cosine and sine value. To do that, we have to know the sine of cosine and sine of sine in the second quadrant. In the second quadrant, x values are negative, so cosine is negative and y values are positive, and so sine is positive. And the reference angle is 30 degree. So this one is adjacent and this is opposite. So let me clarify for this part, 1 over square root of 2. I just orally described that square root of 2, and square root of 2 times 2 is 2, and this one will make square root of 2. Why did we place 30 degree here? Because we are considering the reference angle. Reference angle is 30 degree. We want to use the reference angle and the reference triangle and sine of the trigonometric function on each quadrant. You can keep typing the question if something is unclear. So what I'm trying to say is a square root of 2 over 2 can be written as cosine value in the second quadrant is negative, and so negative cosine of reference angle, because we want to use the reference triangle, so we relate 150 degree with 30 degree, minus square root of 2 over 2, and sine value is positive, and so we don't put minus here. Instead, we think about sine of 30 degree. And from here, we know that sine of 30 degree is 1 over 2, opposite over hypotenuse, and sine cosine of 30 degree is square root of 3 over 2. So we can evaluate one by one, and then that is square root of 2 over 2 minus cosine value is square root of 3 over 2 minus square root of 2 over 2. Sine is 1 over 2. So this is 4 in the denominator minus square root of 6 minus square root of 2. So in the previous class, someone asked me why I didn't put 2 in the denominator. Definitely, there was some confusion about the common denominator and the multiplication of fractions. In this case, 2 fractions are multiplied, and so the denominator must be 4. 2 and 2 are not the common denominator. Those are just multiplied, and then we realize that 2 fractions denominators are the same, that is 4. So we put 4 here. No, it is a rigid form. This is a triangle identity. So 30-degree must be the angle on the top. We are evaluating cosine of 195-degree without using calculator. So that's what we are doing. And to do that, we use the well-known angle values, which we can evaluate without calculator. Type your question on the chat box, and I will ask you. I will answer your question. Let's do the next problem. The next problem is cosine of 29 pi over 12. So today's lesson will not be in the exam. It'll be on the next exam. I mean, just a exam 3 range. Exam 2 range, we already did it because those are up to the law of sines and law of cosines. So again, this is unfamiliar angle, but we want to relate that with the well-known angle in a sum or difference form. So, but before we do that, what we notice here is this fraction is pretty large. So we want to reduce the fraction by using the coterminal angle. So we subtract 2 pi. So is the exam multiple choice? It depends on the problem, right? But you already know the pattern of the problems because I'm selecting the problems from the WebAssign problem pool. So you already worked out all those problems, and those are just the selected problems. So you know all the pattern of the questions while you're doing homework, right? Though of course, those problems are equivalent but not the same. (29 pi over 12 minus 2 pi is 24 over 12. So that is 5 pi over 12. So what I did was coterminal angles. So cosine of 29 pi over 12 is cosine of 5 pi over 12. As we have been doing, what we want to do is we want to relate that with the well-known angle. So let me list the well-known angle. Well-known angles are pi over 2, pi over 3, pi over 4, and pi over 6, and so on, and so on, and so on. We want to combine those angles with the given angle whose denominator is 12. So we convert all those angles into the format of the angle whose denominator is 12. So pi over 2 can be converted into 6 pi over 12, and pi over 3 can be converted into 4 pi over 12. Pi over 4 is converted into 3 pi over 12, and pi over 6 will be converted into 2 pi over 12, and so on. So of course, what must be in the numerator is something to do with what multiplication will make 12, right? Because we have to multiply the same thing to the numerator and denominator. And then we have common denominator, and we will relate that with the addition and the subtraction form. That is 5 pi over 12, so we add these two, and that is equivalent to adding pi over 4 and pi over 6. So we eventually write cosine of 5 pi over 12 as cosine of pi over 4 plus pi over 6. Once we have done it, we can relate that with the sum formula for cosine. So it goes like cosine, cosine, then switch the sign in the middle. So the connect with minus and sine, sine. So cosine of pi over 4 times cosine of pi over 6 minus sine of pi over 4 times sine of pi over 6. So we already know that cosine of pi over 4 is square root of 2 over 2, and cosine of pi over 6 is square root of 3 over 2. If you cannot think that well, then you can just visualize by drawing the triangle. This is adjacent, this is opposite, and this is hypotenuse. So cosine of pi over 6 is a square root of 3 over 2 minus sine of pi over 4 is square root of 2 over 2 times sine of pi over 6 is 1 over 2. So this is 4, and the numerator is square root of 6 minus square root of 2. Any question? How did we get 4 in the denominator? I multiply the digit 2. 2 times 2 will make 4. And so let me write it down. So square root of 6 over 4 times 2 times 2 will make 4 minus square root of 2 over 4. So what I said in the previous problem is what? You have to know all the triangle identity for tomorrow's exam. It's a very important problem. 1 square root of 2. This is pi over 4. So that is 1 over square root of 2, and I rationalize that to get square root of 2 over 2. And what I was saying about this problem is these are multiplication of fractions, not the addition of fractions. And so even though the denominators are the same accidentally, that doesn't mean that we combine that with 2. Instead, we have to multiply those denominators. Let's do the next one. Next one is about tangent of minus 17 pi over 12. Again, what you can notice from here is that the fraction is large. So this time we will add 2 pi to get the smaller fraction. So minus 17 pi over 12 plus 24 pi over 12. So that is 7 pi over 12. So those two are coterminal angles. Because of the coterminal angle properties, those angles' tangent values are the same. Tangent of minus 17 pi over 12 is the tangent of 7 pi over 12. So what we will do will be, we will combine the angles, well-known angles, to get 7 pi over 12. So we will list the well-known angles. Those are pi over 2 and pi over 3 and pi over 4 and pi over 6 and so on. And then I said the denominator is 12, so we will make all the well-known angle with denominator 12. So 6 pi over 12, and then 4 pi over 12, and 3 pi over 12, and 2 pi over 12. So 7 pi over 12 is this one, these must be added. So this one is tangent of pi over 3 plus pi over 4. So we use the tangent formula, and then that will be tangent of pi over 3 plus tangent of pi over 4 over 1 minus tangent of pi over 3 times tangent of pi over 4. So we are considering the tangent value. So we will draw the triangle. The involved triangle must be 45, 45, 90 degree, 30, 60, 90 degree. This time we are using pi over 3, so that angle is located here. This is opposite. This is adjacent. Tangent of pi over 3 is opposite over adjacent, which is what? Square root of 3, right? Square root of 3 over 1, which is square root of 3. And tangent of pi over 4 is 1 over 1, which is 1. So plus 1. And 1 minus tangent of pi over 3 was square root of 3 times tangent of pi over 4 is 1. So that is square root of 3 plus 1 over 1 minus square root of 3. how do you know when to use summation, or that depends on the given fraction? But what I was saying was you will just list the well-known angles first, and then think about the common denominator and convert that into the common denominator for all the fractions. And then you have to just look at the numbers to see whether you have to use the sum formula or difference formula. For example, if the given one is like pi over 12, let's say pi over 12, then in that case, this is smaller than anything else. So you will think about what to do with these angles. And then you realize that, oh, you can combine with this one minus this one, or this one minus this one. And so there are two options, and you can choose either one because those will produce the same answer. I didn't turn 7 pi over 12 into pi over 3. 7 pi over 12 can be obtained by the sum of these two angles. That is essentially the same as sum of pi over 3 and pi over 4. Am I answering your question in the way you are asking me? So I'm not quite understanding what you typed or how did, yeah, okay, good. So any other question? In this case, I believe the WebAssign will accept this answer, but if you wanna try a shorter, rather than shorter the rationalized form of the answer, then you can multiply its conjugate 1 plus square root of 3 on the numerator and denominator. And then you will do FOIL in the denominator and numerator to get the value. So 1 plus square root of 3 minus square root of 3 minus 3. And then the numerator is square root of 3 plus square root of 3 plus 3 plus 1 plus square root of 3. So denominator is minus 2. And the numerator is 4 plus 2 square root of 3. So that is 2 times 2 plus square root of 3 over minus 2. So these two will cancel each other, and minus 2 plus square root of 3 equals minus 2 minus square root of 3. So this is another answer, which looks a little bit simpler in this case. Any question? Would both answer work for the next exam? Yes. So yes, I think the WebAssign will accept both answers. You can do experimentation. The remaining pattern of the problems in this section will be the backward reasoning. Let me copy the problem. Find the exact value. The first problem is sine of 14 degree times cosine of 31 degree plus cosine of 14 degree times sine of 31 degree. So it becomes like sine cosine plus cosine sine. So what is this? As this is the pattern of sum formula for sine, right? So that is sine of 14 degree plus 31 degree, and that is sine of 45 degree. So that was 1 over square root of 2, or you can also write it down as square root of 2 over 2. Second question is cosine of 13 pi over 15 times cosine of minus pi over 5 minus sine of 13 pi over 15 times a sine of minus pi over 5. Cosine of 13 pi over 15 minus, actually it is plus minus pi over 5. Why is that? Because cosine and cosine are combined, and sine are combined. So the same kind of things are combined. So you have to relate that with the cosine formula. And then when it comes to the cosine formula, if that was plus and then it'll be minus, and it was minus and it'll be plus. So you have to switch the sign of the middle part, and so I put plus there. So when you add them up, we have cosine of 12 pi over 15. Oh no, it is just a 5, right? So equals cosine of 13 pi over 15 minus 3 pi over 15. We have to use the common denominator. So that is cosine of 3 pi over 15. So that is cosine of pi over 10 pi over 15. And so that is 2 pi over 3. Right. Any questions so far? It is just a straightforward calculation. We have to evaluate cosine of 2 pi over 3. So we locate the angle in the quadrant to use reference angle. So this is pi, which is 3 pi over 3. 2 pi should be located in the second quadrant. So this difference is pi over 3. And then we want to use the reference angle and the sine of cosine in the second quadrant. In the second quadrant, sine is, cosine is negative. So sine of 2 pi over 3 can be written as minus cosine of pi over 3. So that is minus 1 over 2. Let me just do one by one. Okay, so are you okay with this one, Sunny? And the next request. All right. The next question is tangent to pi over 18 plus tangent to pi over 9 over 1 minus tangent to pi over 18 times tangent to pi over 9. Obviously, this is something to do with tangent formula. And I said the numerator looks like a distribution, even though that is not actually the distribution. So we will use the way we remember. And then when we combine all those, it becomes tangent to pi over 18 plus pi over 9. So we have to think about the common denominator, then tangent to pi over 18 plus 2 pi over 18. So that becomes tangent to 3 pi over 18. So that becomes tangent to pi over 6. So this time we will use the triangle, the same triangle, but only the top portion. So this is 1 over square root of 3 because this is opposite and this is adjacent. Any question? So that is the end of 7.2. And 7.3 is about the double angle and half angle formula. All the double angle and half angle formulas can be driven from what we know with sum and difference formula. Let me state the double angle formulas and then I will show how those formulas are driven. Sine of 2x equals 2 times sine of x times cosine of x. And the cosine of 2x equals cosine squared of x minus sine squared of x. And also it can be written as 1 minus 2 sine squared of x, and it is also 2 cosine squared of x minus 1. And the tangent of 2x equals 2 times tangent of x over 1 minus tangent squared of x. You know, for tomorrow's exam, there are a variety of different things. It starts with the graphs, which are more complex than the first exam's graphs. And then it transitioned to the law of cosine and law of sines. And so you have to use triangles and also graphs, and there will be variety. For the review, you have to go through the bonus exams. Right, in the exam 3, the major difficulty for the exam 3 is more about whether you remember all the formulas correctly. The reason students got low score in exam 3, this type of material, is because they couldn't remember the formula correctly. And so there is a lot of possibility that the students cannot remember clearly whether that should be connected with plus or minus, or there are many subtle things in the formula. I wouldn't say that that is too hard to remember as long as you repeatedly do that. And there is a thinking principle. As I said, sine must be combined with both type, sine and cosine, but the middle part will be the same. In the cosine, just they are combined with the same kind, but middle part will be different. And the tangent and so on. So it looks like a distribution, and the denominator, it's related to multiplication, but it flipped the sign. So whatever the reason is, you have to remember all those things very, very clearly. Otherwise, you will not be able to do well in the exam 3. Let's do a sine of 2x, but double angle formula is easy to derive from the sum formula. Sine of 2x can be written as sine of x plus x. So we use the formula, then that becomes sine of x times cosine of x plus cosine of x times sine of x. And so that is 2 times sine of x times cosine of x. So that's how the double angle formula for sine is driven. And let me talk about the law, the double angle formula for cosine. Cosine of 2x can be written as cosine of x plus x. So that is cosine of x times cosine of x minus a sine of x times sine of x. So that means cosine squared of x minus sine squared of x. Right, that is just a straightforward formula, because that can be related with the sum formula. And then other variation of the formula comes from the Pythagorean formula. So let me start with the Pythagorean formula. Those are cosine squared of x plus sine squared of x equals 1. So cosine squared of x can be written as 1 minus sine squared of x, and sine squared of x can be written as 1 minus cosine squared of x. So we will apply this to here, and cosine squared of x can be written as 1 minus sine squared of x. So cosine squared of x is 1 minus sine squared of x minus sine squared of x. So that is 1 minus 2 sine squared of x. And then sine squared of x for this part. So cosine squared of x minus sine squared of x is 1 minus cosine squared of x. So cosine squared of x minus, we distribute it, so minus 1 plus cosine squared of x minus will make plus. So that can be written as 2 cosine squared of x minus 1. So we have driven 3 different formula for cosine. Double angle formula for the cosine. Any question? All right. The next one is about evaluating the given expression. The problem becomes a little bit more abstract than direct by giving you the actual angle value. Evaluate the expression under the given condition. Cosine of 2 theta when sine of theta equals minus 8 over 17. Theta in quadrant 3. The angle is not given. Instead, the abstract angle is given with the angle's condition, where it is located, what the sine value of the angle is. But we need to start the problem with the double angle formula. So cosine of 2 theta was cosine squared of theta minus sine squared of theta. We already saw that. And what we know in the condition is sine value. So here, instead of cosine, we will use the expression with sine. To do that, we will use Pythagorean formula. And so as I explained, instead of cosine squared, we will write 1 minus sine squared. So that is 1 minus 2 sine squared of theta. So once we converted the equation into this format, we can just plug this value into here. It doesn't really matter in this problem whether theta is located in quadrant 3 or 4. The value matters. And so 1 minus 2 times minus 8 over 17 squared. So that is 1 minus. What you shouldn't be confused about is minus is not plus. It is minus is under square. So minus will make plus, and so middle part will stay as minus 2 times 8 over 17 squared. So that is 1 minus, denominator is 289, and the numerator is 128. And indeed, you can use your calculator. So what you can do is we evaluate 8 divided by 17 and evaluate that fraction and then squared times 2. And then we evaluate this part, but we have to change the sign and we have to add 1, so plus 1. And then we have this value and we want to change that to fractions. So we have to use second and left arrow button. And then we have 161 over 289. I don't quite understand what you're asking. Where did the sign go? So sign was given as this one. And so instead of sign, I replaced the sine of theta by minus 8 over 17. Am I answering your question? Or something else? So you can use your calculator if you don't like to make a mistake. We don't multiply sine with this number because all I did was sine squared is sine theta over times sine theta. Instead of sine, I wrote minus 8 over 17, and that happens twice, and so I raised that to the power. So let me give you the direction. This fraction is first, and then you will evaluate, and then you will square, and then multiply by 2, and switch it the sign and plus 1. So let me show you again. 8 divided by 17, and then you will evaluate the fraction, and but square, it should be squared, and so press x squared. And then 2 is multiplied, so times, no, I have to equal, and then times 2, and then we have this one, and then we have to switch the sign. We have to use this button, and then we have to add 1, so plus 1. And this is a decimal form. What I was saying was you have to get the exact value. So you have to convert that into the fraction. So second and left arrow. Let's do the next problem. Next problem is tangent of 2 theta when cosine of theta equals 7/25 and theta in quadrant 1. This is a double angle case for tangent function. So we start with the double angle formula for tangent. And so 2 tangent of theta over 1 minus tangent squared of theta. So that is 2 times tangent of theta times 1 over 1 minus tangent squared of theta. So, therefore, we have to evaluate tangent. What's given is cosine theta value for the angle, which is located in the first quadrant. Cosine of theta is x over r in coordinate definition. So that implies x equals 7 and r equals 25, and we don't know what y value is. If we apply the Pythagorean formula, then x squared plus y squared equals 25 squared. So x squared is 7 squared plus y squared equals r squared is 25 squared. So y squared is 25 squared minus 7 squared. So if you use your calculator, then that'll give you 576. And then y equals square root of 576. If you use your calculator again, then that is 24. So what we know from that calculation is tangent of theta equals y over x. Y turned out to be 24 and x is 7. So 2 times tangent of theta is 24 over 7 times 1 over 1 minus tangent of theta. So 1 minus 24 over 7 squared. So this time we want to calculate 1 minus 24 over 7 squared. We want to use calculator. So what I will do will be do the same thing. We will evaluate 24 divided by 7 and evaluate it, and squared equals, and then switch it sign. And we have to add 1 plus 1. And then we got the decimal number. So we will switch that to fraction. So it goes like this. But the problem is in this case, we are getting a mixed number. Usually we don't use a mixed number, but there is a function key which convert the mixed number to the fraction that is right above the left arrow button. And you can see D over C. To convert the format into D over C format, you will press second and this one. So that becomes minus 527 over 49. So what's going on here is 2 can be written as 2 over 1 times 24 over 7. And this is the denominator. This is the denominator. And we think about 1 over denominator, and so that is a reciprocal of this. So instead of 527 over 49, we write minus 49 over 527. Of course, 7 times 7 will make 49, and so those two will cancel each other. And so we are getting minus 2 times 24 times 49 over 527. You can use your calculator with this fraction, but I would calculate the numerator and denominator. Numerator just and then minus 336, and the denominator is 527. If you want to check whether that is the simplest form of the answer, then you can just plug that into the calculator. 336 divided by 527 and evaluate it. And that is the decimal number, but you can convert that to the fraction. So you're getting the same number. That means that is the simplest form and you cannot reduce further. Any question? So I don't understand why 49, not 7. Because we calculated this, and when we do this, 24 over 7 times 24 over 7. So 7 and 7 must be multiplied. So that becomes 49. And I got lost after we calculated the denominator. Which denominator? Okay. So for denominator, 7 and 7 will cancel each other. So the only number which remains is 527. And then numerator will be 2 times 24 times 49. And what I said was 527 is too big number. And so you don't know whether that is a composite number or just prime number, right? So in that case, what you can do is you just calculate the numerator by using your calculator and put that here. And then to see whether that is the simplest form of the fraction, you will just evaluate the fraction by doing 336 divided by 527 and evaluate it. And then you will convert that into fraction, and then it gives the same number, the fraction. And that means that is the simplest form of the fraction which you cannot reduce further.
Roger, does she know her name?
What? Let's do one more problem for today. The next one is sine of 2 theta when tangent of theta equals minus 1 over 3 and cosine of theta is greater than 0. So we have to calculate with double angle formula for sine. So sine of 2 theta equals 2 times sine of theta times cosine of theta. Then what we will do will be we will locate the angle and then calculate the cosine value. So tangent value is negative when x and y values have different sign. So tangent is negative in the second and fourth quadrant. And cosine is positive when x values are positive. Cosine is positive in the first and fourth quadrant. So tangent value is negative and cosine value is positive. So that means the angle must be located in the fourth quadrant. So this is the angle theta. So tangent of theta, y is 1 and x is 3. So y is -1, so y equals -1. So r squared is 3 squared plus -1 squared equals 10. So r equals square root of 10. So from here, we can calculate sine and cosine. So sine of theta is y over r. So y is -1 and r is square root of 10. And cosine of theta equals x over r. So x is what? X is 3 and r is square root of 10. So this one is 2 times a sine of -1 over square root of 10 times cosine is 3 over square root of 10. So finally, square root of 10 times square root of 10 will be 10, and minus 2 times 3 is 6, and so that is -3 over 5. So 2 times 3, 2 times 5, and so those will cancel each other. But even if this is the simpler case, we can still put that in the calculator to see how the calculator reduces the value, the fraction, to the simplest form. So we will do 6 over 10, 6 divided by 10, and then evaluate it. And we convert that into the fraction form. So second left arrow button, and then it'll give you the simplest one, 3 over 5, right? So any question? After the spring break, we will continue with the half-angle formula. Half-angle formula is a little bit non-trivial to remember. The format of the formula and also the calculation will be a little bit complex. But right now, what is important is taking the exam well tomorrow. But remember that you have to put your efforts until the final exam, because if your exam scores, first and second exam scores are not great, but if you're steadily making progress, then most of the students who studied hard but who are not satisfactory in the first and second exam could do well in the final exam. So potentially there is a possibility that final exam becomes 75% of the course grade if you fall into that case. But I hope everybody fall into the case that you do well in the first and second exam, and then 50% of the course grade is secured, and so you will feel much better. But otherwise you will feel pretty uncomfortable until the end of the semester. But anyway, do your best today, and see you tomorrow.